ABB relay. So we'll show you on the 132 kV protect relay. Have we received Intertrip? Yes, we have received. As you can see, this LED number 2 is on now. So we are getting the Intertrip signal from 11 kV protect relay, 11 kV side. Actually, this signal initiates from the ABB relay of 11 kV switchgear, and it comes through fiber optic cable to the 132 kV protect relay. So that was the last condition. So I will summarize the signal. This signal was an intertrip from 11 kV switchgear to 132 kV switchgear based on the three conditions: transformer mechanical trip, that also we checked. Secondly, if there is 11 kV circuit breaker failure. Thirdly, if there is an 11 kV unfall in the signal list. So we check this signal. So we have checked this signal now. Now we move to the next signal. This is the last signal. This signal is also from coming from 11 kV and going to the 132 kV side. So this is serial number 5. So this is serial number 5. So what is this signal? So this is again an intertrip from 11 kV switchgear to 132 kV switchgear. This is again another intertrip signal, but on different protection. This is on the transformer protections, transformer electrical protection, which is transformer differential relay at 11 kV breaker or transformer restricted earth fault trip at 11 kV breaker. So these protections, these differential protection and REF protection, these are in the 11 kV protect relay. So this signal will be initiated by the 11 kV protect relay, and this signal will be sent to 132 kV protect relay through fiber optic cable, and the 11 kV protect relay will also share this signal with ABB relay through hard wiring. I'll show you. This is the signal list. So this signal is initiating at the 11 kV protect relay. You can see this. This is 11 kV protect relay. These three columns are 11 kV protect relay. So we are at signal number 5. So this signal is binary output 1. Binary output 1 of 11 kV protect relay. So this is binary output 1, and it is going to binary input number 3 X120 card ABB relay. So ABB relay is getting this signal for indication. ABB relay is getting this signal, and also for trip, because on this signal, on differential protection or REF protection, the breaker has to trip. 11 kV breaker also has to trip. So that's why this. But the protect relay is also directly tripping the breaker, the 11 kV breaker. So, and at the same time, the protect relay sends this signal over a fiber optic link to 132 kV relay. So for that we have configured LED number 3, I think. Yes. So for this signal, in order to check the signal on 132 kV side, we have configured LED number 3 on 132 kV protect relay. So let's check the signal. How we are going to check the signal? We will force these protection functions from 11 kV protect relay, because these protection functions are only in the 11 kV protect relay. So we will be using the software, the relay software, protect relay software, which is Dixie version 4, to force the differential and REF protection. So we will proceed one by one. First we'll do differential. Let's check the normal condition now. What's the condition now? So everything is normal. Let's check the ABB relay. There is no red LED. Everything is normal. So also on the 11 kV protect relay, everything is normal. Only these two LEDs are on. What are these LEDs? These are CB close permission. It means 11 kV CB close permissive from 132 kV. So we are allowed to close the breaker now. So that has nothing to do with any error condition. Earth switch close permission. We also have the permission to close earth switch from 132 kV side. So this is 11 kV earth switch close permission. So everything is normal here. Let's try putting this breaker on differential protection. I'll show you on the 132 kV side, the LED number 3 is off. LED number 3 is off on 132 kV side. So the engineer I will focus here, and the engineer will force the differential protection. You see, he has forced the differential protection, and we have received the intertrip on 132 kV. This is 132 kV protect relay. So we have received this intertrip on 132 kV. So I'll show you on the 11 kV protected relay in which we actually force this signal. So this is 11 kV protect relay. As you can see, it is showing differential protection. So the differential protection was forced through the protect relay software, and we got this differential protection. And this differential protection was also sent to the ABB relay. As you can see, it is at binary input number 3 X120 card that I showed you earlier in the signal list, that it is this ABB relay is receiving the signal at X120 card input number 3. So we are getting, and on the 132 kV side I have already shown you the signal Intertrip on 132 kV. So we are checking. So let's normalize this and check this on the next protection. Show you the engineer, how the engineer is forcing the differential trip. So now he has normalized the differential trip, and now he will search for the REF trip in the software. So he has searched for the REF trip, and now he will send it. So he has sent the REF trip now. Force the REF trip. So first we will show you on the 11 kV protected. So this laptop is now connected through this link, the USB to serial converter. So this is the USB to serial converter. So this laptop is connected through this converter to this Ciprotec relay, 11 kV Ciprotec relay, because we are using the relay software to connect the laptop with this 11 kV Ciprotec relay. So as you can see here, now that he has forced the signal, we are getting the REF trip on 11 kV Ciprotec relay. This is 11 kV Ciprotec relay. And we also have this signal on the same input on the X120 ABB relay card, input number 3, it's true. That means the 11 kV Ciprotec relay has tripped on REF protection, and at the same time this return is sent to the 132 kV Ciprotec relay. As you can see here, this is 132 kV Ciprotec relay on which we are receiving the Intertrip signal, LED number 3. So that's complete. That completes the test of the last signal. It was the Intertrip signal from 11 kV switchgear to 132 kV switchgear based on the differential and REF protections of Ciprotec relay. So we have checked this signal on the ABB relay, on the 11 kV Ciprotec relay, and on the 132 kV Ciprotec relay. So we have completed 6 signals. 3 signals were from 132 kV side to 11 kV side, 3 signals from 11 kV side to 132 kV side, and we have 2 other signals. How many signals we have? 6 completed. 6 completed. So last 2 signals, rather 3 signals we have. These are related to the test switch. These are not being transmitted to 132 kV side. These are just local signals on the 11 kV side. As you can see, these 2 signals, test switch status. Okay, so not applicable. It's not transmitted through the fiber optic link. And these signals are coming on binary input 1 and 2 of the 11 kV Ciprotec relay, and they also have nothing to do with the ABB relay. So no interface with ABB relay, and also no interface with 132 kV Ciprotec relay. So we will check these signals. This the first signal, which is configured on binary input 1 of 11 kV Ciprotec relay, it is related to the test cover. So if we remove the test cover, if the test cover is inserted, it will be high. If the test cover is removed, it will be 0. And the purpose of this signal is to block the differential protection or the REF protection. Like when you remove the test plug for testing, the test cover for testing, then this blocks the differential protection through this binary input 1. So we'll show you the status of binary input. Right now, let's show this is 11 kV panel, 11 kV Ciprotec relay. The test block cover is there in place, and we'll show you the binary input number 1. As you can see, the binary input 1 is high on the Ciprotec relay. Okay, the binary input 1 is high on the Ciprotec relay. Now we will remove this cover. Before I remove, check the differential protection. Okay, so let's check the differential protection will be enabled active. As you can see, differential protection active on. So that means the differential protection is active now. This is the relay software, and we are getting the real-time status of the relay. So now we will remove the test plug cover. I will show you this binary input again. So this is 0 now. The binary input is 0 now, and we'll also check the differential protection. Now the differential protection should be blocked. It should be shown as blocked. As you can see, there is a status, another status, which is differential protection is blocked, and that is on. It means differential protection is blocked. And also all the protections of the protects have been blocked. Restricted alcohol protection also switched off on. It means switched off is true. It's because we have removed the test cover and we are going to test the relay to secondary or something else. So that's why. So another signal is coming on binary input number 2 of the 11 kV Ciprotec relay. The purpose of this signal is to show if the relay is in test mode or not. So for that, when will show you when the test cover is inserted or removed, this will remain as 1. But when we insert the test plug, then this signal will be 0. The binary input 2 will become 0. That means at that time the relay will go to test mode. We will show you this operation. First of all, the binary input 2, as you can see, it's high. Okay, there is no cover here in the test socket. So we will simulate the test plug insertion by inserting a strip in between terminals 16 and 15. So that means now we have inserted the test plug. So now you can see the binary input 2 is 0 now. The binary input 2, and the relay is in test mode now. We have configured an LED for that. You can see LED number 7. This is 11 kV Ciprotec relay, and it is in test mode now because the test plug is inserted here. So that's the purpose of this signal. It is coming on a BI binary input number 2 of 11 kV Ciprotec relay. So we have tested 8 signals. Now, where is it? So this is the 9th signal now. 9th signal. It is the communication failure. Communication between 132 kV and 11 kV. So that's it's related to the fiber optic cable link. So if that fails, we will have an alarm. So for this, we have configured an LED on the annunciator available on the 11 kV switchgear incomer panel. We will see an LED. For that, we will remove the fiber optic cable from one side, disconnect the fiber optic cable. First, let's show you. This is the 11 kV incomer panel, 11 kV switchgear incomer panel, 11 kV Ciprotec relay, ABB relay, and this is the annunciator 11 kV. So here we have an LED number 6. If you can see the annunciation number 6, communication alarm between 132 kV and 11 kV. So what we are going to do is we will remove disconnect the fiber optic cable from the back side of 11 kV Ciprotec relay. Okay. So we have the alarm. You can hear the sound. This LED is making the communication alarm between 132 kV and 11. So this is blinking. So we have the communication alarm. So that's it. So that was the last signal, the ninth signal. So in total, we have 9 signals. 3 going from 11 kV Ciprotec relay to 132 kV side. 3 coming from 132 kV side to 11 kV. And 2 signals are related to the test plugs, local test plugs, and the 9th signal is for communication failure. So we have checked all these signals. We have simulated the complete path of this signal starting from 132 kV all the way up to the 11 kV Ciprotec relay and also the 11 kV ABB relay to check the actual interlocks with the switchgear. So this completes our testing of the testing of the interface list, the interface signal list. LEDs configured. We have also shown you the LEDs that we have configured on the 11 kV Ciprotec relay. So this is the 11 kV Ciprotec relay. I will show you again for a recap. This LED 1 configured for differential protection, 2 for REF, 3 for thermal alarm. So these LEDs thermal alarm were checked during the protection function test of the Ciprotec relay. Protection function test through secondary injection. These were checked during that time. We have a separate video for that. Then Intertrip and CB close permission, yes, our switch close permission relay and test mode. This we checked today during our signal testing. So this completes. I would again reiterate that we tested this with after configuring the other relay as 132 kV relay. This is the other panel. So in order to simulate the 132 kV side, because in the e-house we don't have the 132 kV system, so we configured this relay for 132 kV side, and we checked the interface between this relay and the relay installed in that incomer panel. So thank you so much for your attention. This completes our signal testing. Thank you.